Hello guys, trust you're doing fantastic. In today's video, I'm going to be exposing you to a typical exam question when we talk about 1's complement subtraction. Now you're going to find a typical exam question like this where you have something like this question that says, what is the 1's complement subtraction of 28 from 48? Now this is not going to tell you if it's a case 1 or case 2, all right? And then this is not going to give you any rules reminding you on how to solve this kind of question. All you need to understand is you need to understand the basic rules, which is the most important thing, which is first and foremost understanding how to arrange the question, like I said before. Now let's go straight to the solution. Now 1's complement subtraction of 28 from 48 means that you need to write it this way. It means that 48 minus 28. This is what it means. So in this case, we have the large number minus the small number. So this is very easy. Once you're able to arrange it properly this way, it means you're already 50% ahead. You already solved the question 50%. You're 50% close to the final answer. That is what it means. It means you understand how to represent the question. All right. So the first thing we need to do, the first step we need to take is we need to get the actual binary of 28, which is nothing but the subtrahend. Now this is the subtrahend 28. We need to get the binary, the actual binary. But take in mind, you need to understand something. Now the minimum number of bits required to represent 28 is going to be smaller compared to 48. So in this case, you need to understand that you need to also get the binary, the actual binary value for 28, so that you can know how many zeros you need to pad. You need to pad 28 in order for it to have equal number of bits. This is very important. All right, so now if you get the actual binary of 28, which is the subtrahend, this is 28. So 28 in binary equivalent is going to be 11100. So this is the minimum number required to represent 28 in binary. Now, but then because of 48 is going to have 1 2 3 4 5 6 bits, we need to add padding of 0 in order for it to have equivalent number of bits with 48. That's why we introduce this 0 in red ink, telling us that we have padded. All right, so that is what it means. Very easy. Now from this point, we're going to take 1's complement of 28. All right, so the 1's complement, that is step 2. The 1's complement of 28 is nothing but the inverse of what we have here. So where we have 0, we have 1. We have 1, we have 0. We have 1, you have 0. You have 1, you have 0. Where you have 0 0, you have 1 1. So this is the complement, the 1's complement of 28. This is the answer. All right, so if you use this direct method, you understand what I just did to represent 28. All right, so representing 28, you have the highest number of the place value is going to be 4. So you're going to have 16, 8, and 4. This is going to give us 28, and then you have 0 0. All right, so because of 48 is going to have 6 bits. All right, so that's why we included 0 here. So let's go. You're going to understand what I'm trying to say. All right, so step 3 says add the result. So add it to the minute, which is 28. Like I said, let's get the actual binary of 48. So add the result, the first complement of 28. Add it to the minute, which is 48. Now let's get the actual binary of 48. It's going to be 110000. If you come back to this direct method, you're going to see that the highest number of the place value is going to be 5 raised to power 5, 2 raised to power 5. So for we to get 48, it's going to be 32 and 16. That is going to give us 48. So this is going to be present, and the rest, the other values, are going to be absent. That's why we have 110000. Right, so 32 plus 16 is 48. So this is how we go. So this is 6. The numbers of bit is 6. So that is why we've included an extra padding, extra bit of 0 for 28. Alright, so that's why we included the extra bit value for 28. That's why we included 0, so we can have 6. Alright, so when we take the first complement of that, we got 1. Okay, the inverse of 0. Alright, so that's pretty very easy. Since we have dealt with that, now we have seen we have gotten 48, the actual binary of 48. Now let's add the complement to 48, the complement of 28 to the minute, which is 48. So we have 1 0 0 0 1 1. Okay, so this is the first complement of 28, which is in 6 bits. Now the actual binary of 48 is 110000, which is also in 6 bits. So it means these 6 bits are equal. So it means the operation can proceed because we have equal number of bits. Now let's proceed with the addition. 1 plus 0 is 1. 1 plus 0 is 1. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 is 0 with a carry of 1. Now this carry of 1, since we don't have anything at this point, so we bring it down. So we have 1. So it means at this point, carry is generated. Now what is the rule when carry is generated? The rule says when carry is generated, what we need to do is that we need to add the carry to the result in order for we to get the actual value. So since this is the carry, all we need to do, we need to add the carry to this result. So we take this carry to this point. All right, we need to add it. So at this point, this carry that we have gotten at this point, so we have moved it to this part, right? So this, you can then close this. All right, so this is what we're going to get. We're going to get 0 1 0 0 1 1 plus 1. Now let's carry out this operation. Now if you notice, each time carry is generated, the number of bits is going to increase by 1. So we have 7 bits. So it means that we need to perform this operation in order for we to reduce this number of bits to 6, so that it's going to match with what we have with the minus n and the subtract n. So this is how you check your result as well. So since we know the last rule, carry is generated, we need to add the carry to the result. So in that case, we're going to have 1 plus 1 is going to be 0 with a carry of 1, right? So you add the carry here, you're going to have 1 plus 1 is going to be 0 with a carry of 1. So you put the carry at this place. 1 plus 0, you're going to give you're going to get 1. 0 plus 0, you bring the 0 down since there's nothing. Rather, you have 0, 1, you bring it down since there's nothing, and 0, you bring it down since there's nothing. So at the end of the day, we're going to get 0 1 0 1 0 0, which will give us 6 bits. So in this case, if you convert this bit into decimal, you're going to get 20. So hence 0 1 0 1 0 0 is equals to 20. This is pretty easy. So since carry is generated, we add the carry to the result to obtain the correct result. Note that the final result is said to be positive. So this is a positive result. Each time carry is generated, we all know it's going to take us to a positive result. So this is how easy it is. Now if you have to perform the direct operation of the decimal value, if you say 48 minus 28, you're going to get 20. Alright, so that tells us that what we have done is correct. So I'm going to encourage you to pay attention to the subsequent videos in this channel, because I'm going to be bringing you more and more examples. Alright then, enjoy this video. Bye.